As we get ready to dive into the world of computer programming, we want to make sure you have some sense of exactly what we are doing. Sometimes computer programming can almost seem like magic. Well, how does this magic actually work? How do we get from an idea of what we want the computer to do to something that the computer actually does? The process that we're talking about is coding and compiling. It can get really technical. Our purpose here is not to get into those technical details, but to approach it as beginners and say, well, just in a really broad general sense, what does it mean to write a program, and how does the computer run that program? In an effort to keep things simple, I really am going to gloss over a lot of details. If you're a knowledgeable computer programmer already, you may kind of wince every once in a while and say, ooh, that's not quite right. It's not my intent to be inaccurate. I don't want to say anything that's wrong, but I am trying to keep it at a really simple level. To that end, I'm going to skip a lot of details. At this very moment, we're using a computer, whether that's a desktop PC, a laptop, a smartphone, or whatever. It's a computer, and like I said, it can seem magic and mysterious. You probably have this sense that a computer deals with a bunch of ones and zeros and all that kind of stuff. A computer, or a processor, understands a language, and we call that a machine language. It's really scary and technical, and it's created by people who are a lot smarter than me. That machine language establishes instructions that a computer can follow or execute. For example, there's a machine language instruction to add two numbers together. Something as simple as printing the word hello can be pretty complicated and take 10 or 15 instructions, but a computer has no trouble following those instructions. Meanwhile, we're humans. Very few of us understand machine language. We speak a human language. For example, right now I'm using English. There are many human languages out there, obviously. It turns out there are multiple machine languages out there as well, because different types of processors each have their own machine language. A human can know a machine language, otherwise how would it have been invented? But it's really specialized knowledge. Whereas a human language, pretty much all of us know at least one human language. Some of you probably know 2 or 3 human languages, and I'm jealous of that. It turns out that humans and machines have a difficult time communicating with each other. At least at times we do. We've come a long way, for example, in how well machines can understand the things we're saying. But if you've spent any time talking to Alexa or Siri, you know that sometimes the computer doesn't get it quite right. It turns out that's a really challenging problem to solve. There's a big gap between machine language and human language. And that's where the idea of a computer programming language comes in. A programming language sits in that gap and is kind of a bridge. It's something that is easier for a human to learn than machine language, but it's also something that a computer can reliably convert into machine language so that it can execute. You've almost certainly heard of some computer programming languages. Java and Python are pretty well known. JavaScript, C++, there are literally dozens and dozens of them. They've been developed for a variety of different reasons. Some of it is just historical as things evolve. Often it's purpose-driven. Somebody has a problem they're trying to solve, and sometimes creating a new language is a good way to solve that, or to make a set of tools that will help solve that. If you don't know how it works and you look at something written in a computer programming language, it's really kind of confusing. But there is a little bit of stuff in there that you can make some sense of. That's the whole point. You can learn the things that you don't know about a computer programming language. When you sit down at a text editor and you type in computer instructions using whatever programming language you're working with, we call the result source code. That's where we get this term coding, the act of writing source code. So the workflow is, we're going to type our source code into a file and we're going to save that. We know that this source code has to be converted into machine language, so there has to be some kind of translation that takes place, right? Here's where I start to lose some accuracy or some technical detail as I try to keep things really simple. We're going to say for now that this next step involves a tool that I'm going to generically call a compiler. You will have installed the compiler on your computer in order to get started with this whole process. If you're working with Java, you've installed the Java JDK. If you're in Python, you've installed Python 3, and there are similar tools for other languages. Those installation packages have other tools as well, but the most important part, for our purposes right now, is that they include a compiler or something that does a similar job to what a compiler does. At its core, the job of a compiler is to take in some source code and spit out machine language. Again, we're greatly simplifying here, but the workflow we end up with overall is the human's going to type up some source code, they're going to hand that source code to a compiler, the compiler is going to convert it into something that the computer can actually run. As you get into programming, you will learn a little more about these things that I've kind of brushed over and made really general. But hopefully this gives you at least a little bit of context so that now you can get in there and start writing some code.